This one could be a relatively long one, I guess. Got a Sony TC105. This is an old mono solid-state reel-to-reel machine, 3-speed, and well, it's not working. It's got a couple of faults. Let's see what's wrong. This is an old Sony reel-to-reel tape recorder that I got in for service. A Sony Matic, as they called it. This is the mono machine, quarter track. It uses a 2-channel head so that you can actually have 4 separate tracks. So basically, when you play the tape, track 1, and then you turn the tape over and it'll play track 4, and of course 3 and 2 in the forward and reverse direction. So you can have 2 separate programs. If you're playing a stereo tape, you can select the left or the right, but not both of them at the same time. And turn the tape over, of course, to play track the other side of the tape. Has a built-in speaker, but it is only a mono machine. Let's plug it in and see what it's doing. Got my tape with Music Bakery content on. That doesn't sound very good, does it? I think we should investigate that horrible sound that the motor is making. Almost sounds like a rubber idler that's got a flat spot on it, what it sounds like. So we'll start by removing the front cover so we can inspect the transport. It'd be a GIS, more likely, because being Japanese, but number 1 Phillips should remove these screws. Remove the head guard, and I got to remove a couple of screws back here. What else has to come off on this to open this one up? I may have to take these screws out as well. Okay, let's just see why this was making that horrible noise. Ooh. Well, that didn't sound good. Sounds like something just fell out of that. Oh, that was just this. Maybe this knob just fell off this button. And I bumped that over. Okay, let's put the control knob back on so that I can put it into play. I think it's this idler. It's noisy. Let's see here. Yep. Well, not just that. but it doesn't do it on rewind. Is it something on that motor? I bet you it's this. What is this? What the heck is this? What the? What is that? There's something on this pulley. What is that? It's whatever it is, it's cracked. I'm thinking maybe this was somebody's modification to make the 1 7/8 speed 3 3/4 for 60 hertz, because this is a 50 hertz pulley that's on here, as well here when I play the faster speeded tapes. See, that's 3 3/4, and that's 7.5. But the 1 7/8 position is what's used to drive the take up. I think somebody has put something on this pulley. See this yellow? It almost looks like it's tape, but it's rough. And every time this thing rotates, it is making a noise. Right, if I switch it to the next speed up, you see? The more I look at this, the more I think someone's modified this unit to make the 1 7/8 speed 3 3/4 when running on 60 hertz, because the next one down is not that much bigger, and of course it will play faster on 60 hertz. But it certainly is something that's on this pulley. It's got a crack in it here. Of course, when you go into full fast forward, of course it doesn't engage on that portion of the pulley. It engages to this top portion of the pulley where the belt would normally ride to get more torque. So this is just when it's on play. I'm just going to try smoothing this down a bit. It's rough. So I wonder if I can smoothen this down a bit and get some of that noise out of this thing, because it's got a crack in it. That's quieter already. I don't want to reduce the size of this thing much, because it'll obviously affect the speed at the slowest speed. It'll make it play a little slower at the slowest speed. It won't affect the 3 3/4 or the 7.5 because they're using a lower pulley, but it will certainly affect the speed at the slowest speed. We'll try and get this thing a little quieter. So when you look at this hub, you can see there's cracks in it. There's a piece missing from it here too. It actually almost looks like somebody's put epoxy on there and let it dry and use that to increase the speed of the 1 7/8 for 60 Hertz. That's my thinking anyway. But it's much quieter now, so let's go with that. Let's just try playing this and see whether it actually even plays. The client said it didn't play, but it looks like the head guard is come loose, so it's not pulling down the pads, and that might have been why it wasn't getting any playback, because the tape wasn't being threaded over the heads. That screw has come loose, so let's just tighten that screw down. That might be why it wasn't playing. Okay, let's try threading this up now. I don't hear any sound. Well, it's got more problems than just that, because I don't hear any sound playing back, and I know there's something on this tape. Check this out. That erase head is unsoldered. Somebody's been into this machine. Wonder what else I'll find when I pop the chassis out. Which is what we need to do next. I need to pull the chassis out of here so I can see what's going on with the amplifier. So we'll power it down. I can hear the thing clunking like it's got power, like the amplifier's got power, but we're not getting anything from the head. So I have to think that maybe somebody's unplugged something or disconnected something or blown something up inside. I had to leave a couple more screws in the bottom here have to come out from these feet, and then the chassis should lift out, I think. Knowing Sony, probably have to lift out these screws as well from the strap. Am I right? Yes, I'm right. That should lift out now. There we go. Yeah, those other ones I took out, I didn't have to take out. We'll put those other screws back in. Power cord is caught. If I stick my finger in here to the audio pot, we know the amplifier is working, so we have to trace this back to the preamp, and this is the preamp board back here. So I would think something on this preamp board is bad, maybe a bad cap or a bad transistor. When I put it into record, we can hear it click, so you know the switch is actually switching. But there's no signal coming off this preamp board. I should hear a lot of noise when I put my fingers around here, like I do here in this area. That must be near the output, but where's the head plug in? I should hear lots of noise. I don't. Okay, let me just go to this switch here. This is the... That works. I switch it to the other track. getting anything at the head. This is the other end of the head wire here. When I touch the wire, on the head itself, okay, I got sound now. Why wasn't I getting sound before? There's the other head. I should have sound. Well, let's try this again. I don't know why I didn't have sound before, but I seem to be getting sound now when I touch the head. So am I going to get any playback? I am. That's weird. It's going fast, as you've probably noticed if you know that track, but then that is to be expected because this is a 50 hertz market recorder that came from, I think it came from Hong Kong. So obviously running on 60 hertz it's going to run faster. And I don't see a different pulley. Some machines like had a belt that you could change from one pulley to another. But this one here is an idler drive, so to change this to 60 hertz would require a different main pulley here. Now, of course, one of these units, if you're playing a stereo tape, this would select between the left and the right channel, right? Right channel, left channel. But if you have 4-track tape, you can record 2 different programs going each direction, right? Program 1, flip it over, program 2, flip it over again, program 3, flip it over, program 4. But it's playing. Wasn't playing when I got it. Got to figure out which wires go where to hook up that head again. See if we can hook that back up properly. And see if it continues to work. I don't know what was wrong, why it wasn't working. I really didn't do anything other than move a few wires around when I was searching for where the head wires went, unless something was shorting, and I moved it and cleared the short, because definitely there wasn't sound before. When I first tried this here, I put my finger up to the head, I got nothing. Right, I should have got noise, I got nothing. One thing I do not know is which head wire goes to which side of the erase head. So the only way I can find this out is by experimenting. See which side will erase the tape, because it'll erase one track and not the other. If I'm wrong, it won't erase what I'm trying to record on. So I think there might be something on this tape that I can erase. Shouldn't be anything on here that's critical.
Uh-oh, the preamp doesn't work again. I wonder what's wrong with it.
No noise. I should have the buzz of touching that, but from just induction, right? Picking up noise, but again, it has gone silent again. Okay, I've tracked it into the preamp here, somewhere in this area here, around these transistors.
I know you guys are going to say caps, and you'll be wrong.
This is where I was probing with my fingers and it came on. Turn it off for a second and see if it'll go back out. See, now it's not working. Oh, now it's back. Somewhere in here, maybe one of these caps or one of these transistors somewhere on this preamp board is where my problem is. So I think what I need to do is I need to remove the preamp board and check out some of these parts in here. I think that's what I got to do on this one. I should probably go and look for a schematic for it so that I know what I'm looking at. Here we have a schematic for the amplifier section, and we'll see that the head down here connects through a switch to select channel 1 or channel 2. Goes through the record play switch. Now I've put in red here the play position because the switch here is shown in the record position, as you can see. So the signal comes off the head, and one side of the head connects through here and is going to ground. So the signal side of the head, this is the signal side, comes up, goes in through the switch and up in through capacitor C2 into the first transistor stage. From the first transistor stage into the second transistor stage, and then from here through C8 and over to, I believe this is the volume control here. I think that's the volume control. And again through the record play switch and through the power amplifier and out to the speakers. So if these two transistors, this is where I think where the problem might be. One of these caps here has gone bad, or maybe possibly one of the transistors, and those ones I believe are these ones right here in this area of the board, right in there. So what I'm going to do is I'm going to remove that circuit board so that we can check out that portion of the circuit. We'll do that by removing the board. It's held in place by a couple of tabs. There's no screws holding this thing in place. It's just a couple tabs that appear to have to be bent, and the board should be able to be lifted out. So let's bend those tabs and lift out the board. This is a real high-tech way of installing circuit boards. Just a couple of little twist tabs, which of course can only be twisted a few times, and eventually they're going to break, and then you're going to have a problem. We'll remove the record play linkage from the record play switch. Now the board should lift out. I'm just going to cut a few of these wire ties just so that I can get a bit of access to the board. So we can check the bottom, and oh, there's some, looks like a foam pad has gone bad here. So we'll clean this mess up first, and then I want to concentrate on that preamp section. Because we know if I touch the volume control here, which is the yellow lead, this yellow lead here, this one here, it's always working. So the power amp is working, and the power amp is actually on a separate circuit board. That's on this board up here. This board here only has, I think, the 2 transistors, maybe 3 transistors. It's got the oscillator on it as well for the record. So this is the area here where I feel the problem is. To a C631. Looks like the numbers, and the numbers are, oh, to a C402. Where's my 402? See, C631 it says there. The schematic says there 402. C631. This other one here should be a 2SB383. What is this one? 634. So the numbers on the schematic that I've got are not the same. This is also the first revision. Anyway, the numbers on this appear to be a little bit different than what's on here, but I think we can get a pretty good idea of how the circuit operates. It could be a bad transistor, or it could be a one of these caps that's gone bad too, that will certainly cause us to have issues. with the preamp. What I do know is that the audio coming out from here is good. This never cuts out. It's always got sound here, but it seems to be in this area here where the fault is. So I'm just going to try and trace these wires. Tracing the wires, it looks like the oscillator is actually up here. This is the oscillator transformer. So it's actually on a different board, although it doesn't designate the boards here. It just shows the one schematic. That oscillator transformer appears to be this one right up here. This cable appears to be the record bias right there, that one, which goes down to the selector switch to select the record or the erase head, which is this line here. The other side is this one, and this appears to be the input over here for the preamp, right over there. That appears to be the input. And that would go through this capacitor right there. I think it's the one that's on the input. We're just going to remove that one and replace it. See whether anything different happens when we turn the unit on, and see if we have any signal coming off of the head. This is a 33 microfarad Elna cap. We'll just take a look at what shape it's in. Oh, it says 91. 91 microfarads. It's a 33. Way too high. ESR meter on this one. Measuring only 1 ohm, which actually doesn't test too bad. This is the first one I would suspect is problematic, which is this one right there. Direct input. Could be the transistor is bad too. That certainly is a possibility. Or this other cap over here. Or even this one over here. There's 3 of them that could certainly cause this preamp not to work. I'll replace this one. Like I might replace all 3 of these just in the vicinity here. So this one went across here. There's another one right next to it, which should probably be replaced. These transistors have the flimsiest looking leads I've ever seen. I question whether they're any good. Early transistors were very problematic, right? They weren't that reliable. So it's very possible that there's a transistor that's also bad. But let me grab a new cap. We'll replace this one first and see whether we get anything different happening on this unit. Okay, now I'm going to put this thing in play. I should hear the sound on the amplifier there. Put it in play, I should hear noise from the... So I don't hear anything here yet. So that one didn't make an improvement. I'll try this other one over here on the other side. And that one is, I believe, right here. That one. 47 at 3 volts. This is another cap that tested okay on the meter, both capacity-wise and ESR. Looked okay, but it is directly in the signal path, so it's being changed out. I'm starting to consider that it's the transistors, or one of the transistors that's bad. Give this unit power again. As I say, I've got sound there, which is should. Right there, you see. And that is off of this transistor here. I've got sound, but I don't have anything back here. It might be this first transistor that's at fault. This is the one I suspect it might be, is this one right there. Might be that one right there that's at fault. Because I should have sound even without putting this in play. I should have sound. Get my scope in here in a minute. So it's a power issue. It's not capacitors. I changed a couple of them on here that were in the signal path, but this is a power issue. You see, I don't have any voltage. I should have. This is a 24 volt supply feeding in. Goes through R27 and then through R15, but it ultimately ends up over here in the preamp section at C3, which I think is this one right here. So we should have power on here, and we've got nothing. We've got like 0.3 volts. So just tracing this one back, this comes back to this resistor. And the other side of that resistor is there, and it's got 15 volts. On this side of the resistor, we've got 0.3. So either that resistor, oh, and now it just came on. Oh, could that resistor be bad? I've now got 8 volts. This resistor here might be the one that's at fault. Let's just take a closer look. Is it a solder connection? I think it's a solder connection. Take a look. There's the resistor here. When I wiggle this resistor, you can see that it's not soldered down to the board. And it looks like it was never soldered at the factory. Check it out. There's the fault. There's the fault on this one. Let's solder that resistor down. I'll leave those two new caps in there because, you know, there's nothing wrong with the other ones, but they're old, so I'll leave the two new ones in there. But I think we got the problem on this one licked, as they say. So when I turn this thing on, I should hear hum when I put my finger near the record play switch, or the track selector switch. So power on. Found it. So was this resistor here? It was 3.9, I think it was 3.9K right there. That one right there. Where's my pen? That resistor on the circuit. If you're following at home, that resistor was not soldered down, and you can see where the connection was right there. I just resoldered that trace. And that's all I've done, other than changed a couple of caps proactively, just because, you know, we like to blame capacitors for everything. Quite often they're not the cause. That's when I get a good laugh when I read comments from people saying, you know, I recapped my amplifier, I changed every cap on it, and it's still not working. Well, that's because amplifiers generally don't fail due to capacitors going bad. It's usually something else. Yes, caps do fail from time to time, but they don't fail as often as some of the amateurs out there would like you to believe. They actually are. They're the most unreliable component in an electronic circuit, but also they're not, and they cause more problems than any other component in the circuit. But it's not always the case that it's a capacitor that's gone bad. They do cause problems, but usually it's a solder connection problem or something else. And again, transistors can also cause problems, but they're generally not the cause of problems. They do fail, but again, usually it's something else that's gone wrong, like in this one. So it's going to pop this board back in. Crude mounting method. And twist the tabs again. And now we can see if this thing will record and play. And what I'm curious as to, because that erase head was disconnected, if I got it the right way, it's either going to erase the wrong track or it's going to erase the right track. But we can test the unit out now. And see if this vintage old unit is going to do anything. Okay, tape threaded up. So when I put it in record, we'll see if it erases the track that I think I'm on. So record. And good enough. Did it erase that track or not? Nope. But I bet it erased the other track. Yep. Okay. So now I know I got the wires reversed. Let's reverse the two wires so that it's erasing the correct track. This will be an easy one. Just turn off the power because the white and the red wire are reversed. I'll just remove the tape so that I don't melt it. And then I can put this thing back together. And no, it's not going to go the right speed. It's never going to go the right speed. This unit is a 50/60 hertz machine, but it was set up for 50 hertz. So when running in a 60 hertz country, it's going to run the wrong speed because they did not have a pulley that could change. Some machines had a pulley that you could change it from 50 to 60. This is not one of them. This is it's a synchronous motor, which means the motor is synchronized to the incoming AC frequency, and there's nothing you can do to correct it. But if it had been used to make recordings like voice recordings and stuff here, of course it'll play back its own tapes at the correct speed. That'll always be correct. It's just tapes recorded on another machine will Play back at the wrong speed. So there's those two wires out. If you remember earlier in the video, which I'm sure some of you don't, because some of you seem to have a pretty low attention span. I know that because I read comments from people asking about something that in prior videos, they'll ask me a question that was clearly explained in the video, but they obviously either were falling asleep. I have a tendency to do that, put people to sleep. I've had people tell me that they watch my videos when they're going to sleep at night, so I must be pretty boring. Or they were skipping ahead, or they just weren't paying attention. That's like me when I'm watching TV. You know, main character will do something, and I'll be, I'll be kind of half-ass watching. I'm bad at watching TV because I'm usually checking messages on my phone and responding to viewers' messages, and I'll completely miss something that happens, and then, further down in the show, I'll see something happen and say, wait a minute, what happened there? And the wife, she says, well, if you didn't have your nose buried in the phone, you would have seen what led up to that. So I'm guilty as charged as well. Okay, so let's see what happens now. That's the only reason it's doing that is because it's sitting upright, I think. It's a little slow at pulling up the take up, but anyway, let's go to record. And then we'll rewind it back a bit and see that the recording has been erased. So now we know that the record head or the erase head is correct. Let's rewind the tape. I'm going to put the unit back together and then we'll test it. Good old Sony. They put screws in from the top and the bottom, and the handle had to come out. I remember the first time I opened up one of the reel-to-reel machines, I really was confused at trying to open it because of all the different screws that had to come out. This is long before I got into the business. The first Sony reel-to-reel machine I took apart would have been in, I'm going to say probably 1970. Trying to think, 76, 77. I guess my neighbor, who's been dead for like 30 odd years, 40 years, I don't remember what year he died, 1980, I think 1986, no, a little later, 1991, so 30 years ago. But my old neighbor he was a studio musician. He strummed guitar, and he was my guitar teacher, and he also played piano, but he did a lot of session work down at one of the local studios. Did a lot of session work, and he had a TC, I think it was a 635 in his studio. I've got one just like it. I think it was a TC 635, and he had me work on it when I was, I'm going to say it was probably around 1970, 77 or 78 maybe. I was only probably 15 or 16. What was wrong with it was the mechanism was gummed up. The lever that operated all this cam was frozen, right? So, which happens on all the Sonys, and it hasn't happened on this one, which is quite remarkable because this one's in good shape. I'm not even going to bother taking it apart because there's no money in this repair. This is kind of one that I was looking at for a guy, so get it working. And that's the customer that had the EVS 7000 with the dead display. This is his machine. Anyway, the first time I worked on it, it was like, how the hell do I get into this thing? And it was the same thing. It had a handle on the side, and there were screws going through the handle. And anyway, the screws had to come out. And I remember pulling my hair out, trying to figure out how the hell to get this thing apart. When I was just basically just a teenager, just tinkering around with stuff. I'd worked on some radios, worked on some transistor and tube radios at that point, but I wasn't, certainly wasn't serious about this stuff. Not back then, anyway. I didn't start to get serious about electronics until I was actually in high school. Well, even then I wasn't really serious. It was more like a hobby. I didn't get serious about electronics until my attempt to get into broadcasting kind of went sideways and didn't pan out how I had planned it to after going to BCIT and taking the broadcasting course for television. And I found it was a little more challenging to get into that field than maybe I first thought it would have been. And the backup for me was electronics, because I had tinkered around with it when I was younger, and I got a little more serious and started studying electronics at that point, and got very good at it, I might add. I don't know why it's doing. Oh, that's the tone. That's weird. I think that's the oh well, it's oscillating a bit if you turn the tone control down. That's weird. I'm not worried about that. I'm not authorized to do a lot on this unit. Where is the tone control? Somewhere on here is a tone control. Is it this one? No. Is that it? Maybe that's the tone control. Somewhere on here there's a tone control, and for some reason it's oscillating when you turn it down. I think that's the level. That's the record level control. That one. Yeah, that's the record level control, because that's the auto. You turn it to auto. S3, which is this one here. S3 is the auto manual selector, and it's in manual position. So manual position there. Auto just puts a 390 ohm resistor across it. So that one is the record level control. That one's the volume control. Somewhere in here there is a tone control, and that tone control is oscillating. Do we see it? Anyone? Do we see that tone control? I'm looking for the tone control. Not that I'm going to do anything about it, because who turns the tone down on their tapes? So that would be the calibration control for the meter coming off this transformer for when you're in record mode. In playback mode it's bypassed. You see, that's part of the switch. This is part of the record play switch here, and it's in the record mode, which would turn the meter on. When it's in play, it shorts the meter out. And that would be a variable resistor to set up the gain on that meter. Where the hell is the tone control? I'm looking for it on the schematic here, and I don't see a tone control in this amplifier section. It's that one there. So in the play position, the signal would go down through. Yeah, I bet you that's the tone control right there. And it filters out, or it bypasses and rolls off the high frequencies by feeding them back. Okay, that's probably where that is. There's a 0.022 microfarad cap. The signal's coming off of the playback circuit from the amplifier, and it goes through this control, and when you turn it down, it applies a feedback signal through this resistor and capacitor, which then goes back into the preamp stage, and that would roll off the high frequencies, and for some reason it's oscillating. That's the tone control there, but I'm not worried about it. Nobody turns the tone down. I don't know anybody that turns the tone down to minimum. It works until you get past a certain point, and then it starts to oscillate, and it could be oscillating due to a number of factors, like one of these caps is getting weak. But I'm not worried about that. The guy that owns it wants it to play back tapes that his father made and so forth, so they're going to be music and voice recordings, and for music you want the best quality anyway, so you're going to have the tone control turned up. Plus the fact that the head is worn on this thing. If you look at the head is just about shot. Take a look at the wear on this head. You want to talk about worn heads, check this one out. Yeah, there's a fair bit of wear on this head. Whoops, and I just broke it. That sits this other way. That screw came loose. It's got a loose screw. We'll just tighten that one back up. I thought I tightened that up before, and it's now loose again. I guess I didn't tighten it tight enough to get the lock washer to actually lock into place. What that does is this screw here, or this is the tape. This is the tape retractor to pull the tape away from the heads when you're in fast forward and rewind and modes other than play. So it holds the tape away from the head, so you don't hear the tape screeching away because the amplifier is always on. So when you play, and that pulls the tape back, and of course drops down the tape pads that hold the tape up against the head on playback and record. Anyway, the head looks to be fairly worn, but it's still functional. I mean, there's no, I wouldn't change one. I wouldn't change it. It's still going to sound okay for a unit this old. There's some wear on these guides too, but it's not in that bad a shape considering the age of this thing. The fact that it actually still works is amazing. The reason why you get the sound speeding up like that when you put it in play is, of course, the capstan is not driven unless the motor is not driven by the motor unless it's in play. So the reason it's still spinning now is just because of the inertia on here. If I slow this down, you see it doesn't run until I actually engage play. So of course, when it's been sitting there for a while, it's going to start to gradually slow down, but that gives you an idea of just how much inertia is in the flywheel effect on this unit. It's a heavy flywheel. That contributes to low wound flutter. But good old machine. Should we make a recording on it? Let's check out fast forward. I push down the fast forward, and there we go. Fast forward works. Rewind works. The brakes are working. Play works. I don't know if we need to even bother doing a recording on this unit. I'm sure it works. I just don't have a mini phone plug here. I guess I could probably plug a microphone in. I might have a microphone that'll work on this, and we'll just try a quick recording. Just rewind it right back to close to the beginning here. Good enough. Good enough. Let me find a microphone. We'll do a test recording. I got my Mr. Microphone. In this case, it's a Realistic that came from Radio Shack, a little dynamic microphone. When I put this into record, I'm going to hear myself out the speaker because these units have a live monitor, and there's a switch on the side to turn the speaker off. So when I push the record button, I can hear myself, and I can get feedback too. Whoa. Remember all the fun we used to have when we were kids doing this? lots of fun doing that when I was a kid, driving my mother crazy. There is a switch on the side though to turn that off so that I don't have to worry about that. We got our levels here set, and we'll zero the counter, and I'll just press the record button and make a recording. Testing 1 2 1 2 3, and if I want to get some feedback, I can do this. Sound like Ferris Bueller when he was practicing saying, "Never took one lesson," if you remember that from the movie. Okay. Enough fun with this thing. Too much fun with this reel-to-reel machine. Let's play it back. And make a recording. Testing 1 2 1 2 3, and if I want to get some feedback, I can do this. Sound like Ferris Bueller when he was practicing saying, "Never took one lesson," if you remember that from the movie. Okay, I think this one's fixed. It records, it plays. What more can we ask for? I'm going to put it back together, we'll do one final test, and then we'll close this one off. Kind of reminds me of the old Sony. I've got an old Sony. I forget the model number. You guys have seen it, but it's a 4-speed, 15/16, 1 7/8, 3 3/4, 7.5, and it uses a servo motor, a little more advanced. That I've had a few people offer to buy from me, and they've offered me quite a bit of money for it. One guy offered me a couple $100 for it, and one guy offered me even more than that. I thought, well, if I got two people offering me that kind of money for it, it must be worth even more. So I haven't sold it yet. Someday somebody might make me an offer that I can't refuse. Actually, I would have sold it to the guy that offered to buy it, but let's just say I didn't trust him and he didn't trust me. He wanted to buy it from me on PayPal, and he wanted me to invoice him, and I said, nope. You want to buy it from PayPal, you send me the money and I will ship it to you. And his attitude was, well, I want an invoice because I don't trust you. And my response to him was, well, you know what? I don't trust you because if I give you an invoice, then you can dispute it after you've got it and get your money back. Because I fell for that once. I sold one thing to a fella, and I'm not going to go into any details on this, but I sold something many years ago, and after the person received it, they decided that they were going to make a claim, and it was fought for almost a year. They got their money back, and I never got my inventory back. I was out, and it was a substantial amount of cash, like $2,700 worth. Let's center that meter. And today, the day that I'm recording this, is a very sad day in the music industry, as we lost one of the greatest drummers of all time, and that would be Charlie Watts from the Rolling Stones. One of the greatest drummers of rock and even jazz. He was a lot of people didn't know that, but he was in a big band and he played jazz, and that was what he was trained as. He was a jazz trained drummer. Okay, one last time. Oops, that goes on there. That's the pause button. And make a recording. Testing 1 2 1 2 3, and if I want to get some feedback, I can do this. sound like Ferris Bueller when he was practicing saying, "Never took one lesson," if you remember that from the movie. Just gonna loosen this top a bit. That button was kind of sticking there. There we go, a little better. That's it. Thanks for watching. We'll catch you in the next one. Bye for now. So here's some little bonus footage for you guys that want to stick around and take a look at how this thing actually operates. So we can go through the schematic together. So a microphone input, when you plug in your microphone, when it's in record, the signal comes in. When there's no signal, when there's no microphone plugged in, the auxiliary jack here, auxiliary input, will go down through this resistor and into the microphone. There's also another resistor that provides a load, 100K and a 560 ohm load to provide the impedance balancing for the auxiliary input. But when there's no microphone plugged in, that signal will then go through the jack and down this direction. Let me find my highlighter pen. It make it a little bit easier to see what I'm doing if I can highlight it. Audio signal comes in, goes down through here and up. Remember this, I put the red mark in here to indicate the playback position, but in record it comes up, goes through the amplifier into this transistor, and then out from this transistor, out through this capacitor, comes down this way, but it ends at that switch because that switch is in the record position. In playback, that signal would loop up this way. It also comes down this way, goes through this switch in the record position, comes back up, goes into this transistor, which is the amplifier, out from, just looking the way it's going here, it couples out through this C14 into this transistor here, which is the audio output, which then goes through the audio output transformer and back, and through the output transformer, comes back around here. Signal comes back down through this way, where it gets added to the bias. This is the bias oscillator here. It's added to the center tap, so the audio itself is, and then this stage on T1, this is the audio output that goes over to the speaker. But when you're in record, that signal now modulates down into this primary of the transformer, which is feeding the oscillator, so that the actual audio is coupled through this transformer. But one side of this comes out and it ends up going into the head. One tap comes off here. Where is it going here? The head goes into here. So one tap comes off there, goes into the head and back. And then this side of the head is connected. Where are we going to ground? Here. One side of it's going to be grounded. It goes through here and back, through this side of the switch, and returns to ground. So that completes your recording, your audio recording. The audio goes in through the switch, through the amplifier, back down through this side of the switch, through this second stage of amplification, into the primary of the audio. This is the phase splitting transformer that splits the phase for the two outputs. Creates a quasi push-pull, because it's not a push-pull amplifier. You have two NPN transistors. So one transistor conducts on the positive waveform and the other transistor conducts on the negative waveform, and the collector here and the emitter form your midpoint, which is coupled through a capacitor, which ends up going out to your speaker. That's the output capacitor there. But that's used on playback. And of course on record, that's why you have to turn the monitors off, because when the monitor is turned on, when the speaker switch is turned on, which is right there. I think that's the switch there. Or is it, no, S6. S6 is this one. That's the speaker switch. So when that signal comes out, it goes through the speaker switch and into the speaker. The reason that's active is because the same audio circuit is used for playback and record, but it goes through the primary side of the transformer, which is now bridged over and is fed back to the oscillator. In playback, of course, the switch is the other direction, and this one here is now supplied with, what is it, there's a voltage it's supplied with. Where are we here? It's connected over here to this side. Anyway, that's the record circuit, and the erase bias is also through the same transformer, but off of a different tap. Right, a higher voltage tap for the erase. That way, the bias, AC bias, is sent to the record head, which is superimposed with the audio. So basically, what is received at the head is an amplitude modulated carrier, basically. The carrier being at the frequency of the oscillator, which is the same that's supplied to the erase head to erase the tape. So this was an early AC recording circuit that they used on this. Recorders prior to this used DC, so they just took basically the output from the record amplifier and fed it directly to the head, but didn't provide an AC bias signal. Now on playback, as I think I already went through a bit of this before, but in playback, the path is the opposite. The path, one side of the head is grounded, which is this side here, because this switch is now over on this position. So this side of the head that's normally connected to the output tap on this T3 transformer, this side is connected through the switch, which goes up here to ground. The other side of the switch comes through here, and that feeds in. And we're going through the same circuit that the microphone went through. Same preamp circuit, and all the way through to the transformer. The difference is when it's in playback, we've also got this tone control that's not really working on here. As you can see, here's the switch. So the tone control is turned on when it's in the playback side. When it's in the record side, this is open. So the tone control doesn't operate. But the circuit is the same. It's using the same amplifier. You get your same 6 transistors. 2 transistors preamp, mid-level amplification driving the T1, which this is going to be the phase splitter that creates the 2 separate, and these windings of course are out of phase. One side feeds the base of the positive of the amplifier waveform circuit, and the other one feeds the base for the negative of the waveform. So how that works is if we look at this transformer in detail, your waveform going in like that, and on one winding it's doing the same thing coming out, and on the other winding it's doing that. So it's in the opposite. Same level. I drew it not quite to scale, but it's the same level, but it's 180 degrees out of phase. If we look at the 2 sides of the transformer here, you'll see that 2 of them are referenced to ground or referenced to the output. It's actually not ground, it's actually referenced to the center, to the emitter collector output. But these 2 are connected together, right? Feeding in. One side's referenced to ground, the other side is not. So as the 2 coils, secondary windings, are operating out of phase, when one side goes positive, you've got your positive waveform here going up, which will then put a positive signal to this NPN transistor and cause it to go into conduction. At the same time, this one's going negative, so this transistor is in cutoff. When the waveform reverses, this side goes negative, this side goes positive, so this transistor now goes into conduction. So that way you can vary your voltage positive and negative. You're fed off your 24 volt supply. This is your 24 volt supply right here. So you get your 24 volt supply right there going into the transistor. This side here is to ground. Normally when there's no signal whatsoever flowing, these transistors are biased to a partially on state. So there is a slight current flowing through the transistors to keep the circuit alive. But it's the DC voltage is blocked with this capacitor here, so the DC voltage never makes it to the speaker. So what happens is as the audio waveform goes through the transformer, it's influencing one transistor more, making this transistor go into conduction on the positive going waveform, and that happens when the waveform starts to go positive, this transistor goes into more conduction, which causes the voltage here to go up. So the waveform starts to go up in value. This transistor is being forced off at the same time, which of course reduces the drain through to ground, which causes the waveform here, or the voltage, to go up to follow the waveform. And then when it reverses, this transistor starts to go into a more negative bias. It doesn't cut off completely, it just goes lower in conduction, and this one goes into a higher conduction, which pulls the voltage down. So normally if you got 24 volts sitting here, when there's no audio whatsoever, there will be a voltage, and it should be around 12 volts, and indeed it is, because they're telling us that under no signal condition we have 12 volts floating right here. And the reason we have 12 volts is because the transistor is biased on through the bias resistors. It's slightly biased on, so we have a bit of voltage, and that's done through here. You see our 24 volts is also feeding along here through this resistor and down through here, which puts our voltage on here, but it also provides a bias voltage through the transformer, a DC voltage, which biases this transistor on and also returns this way, and through this other secondary provides a little bit of a current through to that one, but much lower. We look on this one, there's 82 ohm resistor here, and this one here is also an 82 ohm resistor on there, and then we have a 10 ohm resistor to ground. So our secondary bias for the second transistor, our 12 or 24 volts comes through 82 ohm resistor, right, through the secondary to provide a bias voltage on the base. It also goes through this 10 ohm resistor, and then back through another 100 ohm resistor here, another 82 ohm resistor, where it can now apply a bias voltage to this transformer, but you'll notice it's a 10 ohm resistor here pulling it to ground. So the bias on this one here is much lower than the bias on that one, and that's what keeps this transistor in a little bit higher conduction. This one's kept just to the point where it doesn't cut off, because if it cuts off completely, then you end up with really nasty distortion. So this is a quasi Class B amplifier using two Class A circuits, two Class A bias transistors. Both transistors are always kept bias on. They're not cutting off, but one is pulled very close to cut off when it's turned off, and same with this one. When the negative voltage comes along, this transistor is not going into cutoff, but is going much lower. So you basically have two transistors that are operating as half Class A amplifiers, one amplifying the positive portion of the waveform and the other one amplifying the negative portion, and this capacitor here is what's basically providing the output to the speaker, and it's blocking any DC, because you have 12 volts DC on one side, and on this side you'll have 0. Otherwise you'd burn out your speaker, because as you notice, the speaker is connected to ground right there. So if that capacitor there were to short, for example, you'd burn out the speaker, because you would have 12 volts going through the speaker coil. So C20 is an important one. If it shorts, game over for the speaker. Anyway, that's just for the geeks out there that want to analyze this circuit a little more. And I'm sure if I wanted to study this, I could go into even more detail. But it's a pretty simple circuit, and I've now put you all to sleep. And I promise not to be like the other guy that goes into detail and spends 3 hours talking about things and really puts this audience to sleep. Anyway, thanks for watching. We'll catch you in the next one. Bye for now.